Thank you for joining us for the Q&A Did You Know session on the Locator One. I've got Tini Nuiten with me from Basetime, Sales Manager. Thank you for joining us, Tini.
Yeah, you're welcome. Thank you, Toby.
So what we're going to do, first of all, is just run through a brief presentation on the basic principles of the Locator One. So the Locator One is a 3D positional monitoring device. So we're looking at absolute 3D autonomous long-term monitoring with sub-millimeter accuracy with a completely standalone device that doesn't require any external comms, any external power, and is fantastic for both geo and structural monitoring. And we'll cover some of the use cases from previous installations, but also some additional opportunities for its use as well moving forwards. So this is the Locator One, and you can see all of the very clever tech that's been packed into what is an incredibly small device. We've got the GNSS antennas, a zero plane indicator, which is a marker down the side of the device so that you can see the level position. The LTE-M patch will come back to this LTE-M connectivity to give a little bit more clarity on what that is and how it differs to LTE GSM connection. A supercapacitor, which is all about its ability to be completely standalone with its own battery and solar panel. The very simplistic clamp on the base, which I know we will cover as well in terms of how this is actually installed on site. A very useful reflection sticker on the side, so this thing doesn't get run into or whacked during low light. We've got bird spikes on the top, which prevent it from being used as a nice pooing station. The radar distance sensor, which we will also talk about during the webinar, giving our absolute height position of the sensor above the strata below. And then the user LED and interface indicators on the underside, along with an ID and a QR code, which is used for identifying and setting the device as part of a full installation. So in terms of accuracy, which is a regular question, the stated accuracy that we have is 2 millimeters plus 0.5 parts per million, but we'll go into more detail on both the horizontal and the vertical, which is stated as 4 millimeter at 0.5 parts per million, as one of the key questions in the webinar. So I won't touch on this too greatly now, but we are talking about sub-centimeter accuracy. There are, of course, considerations around weather, temperature, line of sight to satellites, etc. But it is important to reference that this is a long-term low rate monitoring. So we're talking about measurements that are at a maximum frequency once per hour and as a minimum frequency once every 24 hours. So this is not comparable to installing a GNSS rover monitoring at 1 Hertz. This is long-term slow rate movement that we're observing at sub-centimeter accuracy. So I mentioned the LTE-M. We will touch in more detail on this, but we are talking about the IoT LTE network, not the LTE GSM network, which we're familiar with our phones. There is a useful reference between the two, but as I said, I think it's an important point to cover off because it does impact when the device is suitable for applications, as it is critical that there is an available LTE-M network for the devices to connect to. So in terms of deployment, very, very simplistic. We need a minimum of 2 devices. One which acts as the corrections device, so outside the zone of influence, and one device as the device we're monitoring the absolute position for. Any additional devices are then installed alongside that initial reference device. And there are 3 methods of monitoring, shall we say, that are established within the cloud platform that processes and supports the visualization of the data. And that is the use of these as settlement rods, as object monitoring, and in landslide monitoring. And again, those we can come on to in more detail. If there's any specific question about potential applications that you have in mind, please raise it as a question and we can hopefully answer those for you. And the visualization platform that I mentioned, Parvamoti, is very intuitive, very clean, provides a lot of information with regards to each individual device's position and the data it's capturing. But more importantly, from a project monitoring perspective, we have layouts of the position of each device, their relative position to one another, and then the individual behavior of devices, and again, in relation to one another. So there is a lot of visualization that can be achieved within the Parvamoti platform itself. But very importantly, for a lot of customers, there is full API available for the data to be pushed into third-party software as well. Again, another point that we'll cover off as part of the Q&As. So the real advantages of the Locator One, as I said, we're talking about slow rate monitoring. This isn't rapid high hertz monitoring of dynamic movement. This is slow rate movement over a longer duration of days, months, and years. But this gives a very reliable picture as an alternative to manual processes. We've got an ability to have the automatic notifications. So should we see things that are moving outside of expected behavior, we can receive the platform notifications for that, or API push notifications for that. We see 3D absolute in a complementary reading to 2D monitoring. So this isn't intended to replace an entire monitoring installation. This is very much seen as part of a toolkit to provide a 3D positional reading in addition to other 2D relative movements, tilt movements, expansions from cracks and joints, etc. And should be seen as part of a kit, part of a complete solution, which includes many other sensors and aspects of IoT monitoring as well. I mentioned the API dashboard. I said we'll come into more detail. The fact that the unit is completely standalone, and you can see in the image here, it's sat on top of a nice isolated rod all on its own. There isn't any need for anything additional, no additional power, no comms to be plugged into it. It is a completely standalone device that will recharge itself as well. And from a more broad benefit, we have the benefits of this being a standalone automated device is we remove the need for physical presence to go and take these measurements, and therefore we can use this as an ability to demonstrate CO2 reduction in terms of activity on construction sites, groundwork sites, and infrastructure. And there's a wide range of applications that the device can be used for. I think the most important thing to highlight is there are many opportunities where this could be the ideal solution. But what I've been very impressed with from Basetime is they're very honest when this isn't suitable. So please, by all means, as you start to understand this device and where it might be relevant to a project, raise the question on whether it would be suitable. And that is generally a very useful measure for twofold. One is to understand when it is relevant, but also for the honesty when this is not the right device, which then provides you with that true confidence that this is stated as being a suitable solution. It's done so with confidence and trust that you'd be told if it wasn't going to be a suitable solution for you. We're going to get into some questions. We've had a whole series of questions raised before the meetings. We've got Dan with us, who's going to pose these questions for us, Tatini, who's going to give us some very deep and meaningful answers to them, which I can then interject with any practical feedback or commentary as well, if there's anything that from an experience of an end user that I can add from the manufacturer's perspective. So Dan, if you could pose the first question for us, that'd be fantastic.
Hello everyone, I will be your question master today. So the first question is, can I set the measurement frequency myself? And if I can, how is this done?
Hi, Dan. Thank you very much for this first question. If we talk about frequency, what we refer to is the measurement interval. And the measurement interval and frequency are two words that are used in this, let's say, in the realm of GNSS measurements, but we're talking about intervals. The intervals can be set by yourself by using our platform Parvamoti. The platform is a SaaS platform that is accessible for everyone using the Locator One. And in Parvamoti, you can actually see every single unit that's connected to your project, and you have to do the project settings yourself. So the measurement intervals, alerts, and whatever you can think of related to a project are managed by the user itself.
I'll get on to the second question now. Can the data be visualized, monitored, and alarms set in third-party software like Trimble, T4D, GMOS, and others?
That's a really good question. And the answer to that is yes. We actually use a RESTful API to connect to third-party systems from Parvamoti on. And we've already established some connections with T4D, with GeoMOS, with Delta Watch, Atlas, and Chronos. And those are some of the often used platforms that we connected to. It's really nice to see that RESTful API is one of the most accessible and easy to understand APIs to use, and it's been used in many cases. A lot of our customers are connecting our platform, Parvamoti, to their own platform in order to process data, set alerts, etc., etc. Toby, maybe you can add to that.
Yeah, that's something that for me has been really important with the relationship with Basetime, and it comes back to the point that I made during the overview presentation that Basetime put forward and very much advocate for the fact that this is part of a toolkit of devices that deliver the monitoring. And Parvamoti is a fantastic tool if you are just using Basetime Locator One units, because they are the entirety of the parameters that you need. But even in those instances, more often than not, customers have their own platform, their own visualization method that their clients are used to and wanting to use to visualize the data and reports. So yeah, Basetime's openness to this, the integrations they've already achieved. I work quite closely with another platform called Senmos, another one who've looked at the API documentation and realized that this is a relatively quick integration to achieve. And Basetime have been incredibly proactive with regards to offering that API integration and supporting it as well, actually being there to assist with achieving the API rather than just providing API documentation.
Yeah. Well, thanks for adding to that, and I want to emphasize exactly what Toby just mentioned, is that the sensor we create, our Locator One, let's say in the world of monitoring, and especially when using third-party software that actually collects and processes data from all kinds of sensors, this is just one of the tools in the toolkit. And whether you're using tilt sensors, inclinometers, extensometers, whatever, Locator One with its 3D real and absolute coordinates is just an extra tool for that specific purpose. I think that's something to emphasize. Again, we as Basetime are emphasizing that. Again, this is not a one-size-fits-all device, but if you need absolute coordinates and the high accuracy of this GNSS system, this is going to be the tool to use.
Right, for the third question, how reliable is the reading accuracy at 2 mm horizontal and 4 mm vertical?
Oh, that's a really great one. That's the one I've always wanted to answer. Every single meeting we have with new customers, this is one of the things that comes up, because what our realm of users is used to is RTK GPS, of which we all know that with RTK we can get centimeter accuracy. So how in the world is Basetime capable of generating coordinates with an accuracy of 2 mm and 4 mm? And we have to go back to the science behind this. We are not a real-time kinematic device. Locator One is not an RTK device. It's actually a device that uses fast static and post-processing to calculate the vectors. And it's a very intensive calculation that's being done in a very short amount of time in our cloud solution. If you look at the actual figures, they're even better. If you look at the scientific data below that, we're even talking about single to 2 mm accuracies in both height and horizontally. But since we determined that we're not looking at a single measurement, but we're actually looking at a daily moving averages, we're able to establish a 1 sigma value of 2 and 4 mm. And we've done tests in over very long periods of time. with a once an hour frequency or interval, so to say. And we've noticed that actually the accuracy is a lot higher. But in order to be that high, you need to have the right circumstances. And the right circumstances, as people who are aware of GNSS know, is a clear sky above 10 degrees, the right constellation, the right temperature, whatever you can think of. There are a lot of parameters that have an influence on the accuracy itself. That being said, the 2 and 4 millimeters with using the moving averages is a realistic value, and it is being achieved as we speak with a lot of our clients. What's your take on that, Toby?
So yeah, so certainly from the test units we've run, I have no grounds to counter the claims in terms of the accuracy. We've seen running Basetime units alongside other GNSS devices, very, very high levels of accuracy that are, as you've stated, within the accuracy that is stated for the devices on a repeatability, which has given me great confidence as well. And actually, Tini, I think what is good to hear is the fact that actually the achieved accuracy is often greater than the published level. But this is more about long-term reliability and the variables that are outside of your control of Basetime with regards to the constellations, interference, the weather conditions, temperature, etc. And I know that the confidence in the accuracy is one of the most critical parts when we're talking about any IoT device, and exceptionally when that is talking about GNSS positioning. And I've seen a lot of devices that claim accuracy, which they can achieve, but fairly inconsistently. And what I've felt very confident about with the Basetime is that it is a consistent accuracy. This is something that is, without significant external interference, is continuously achieved.
Yeah, and one thing I'd like to add is it's part of the Basetime culture to under-promise and over-perform. And sometimes you would like to shout it from the top of your lungs that we are achieving these values, and try for yourself. But again, we try to be realistic in this, and these are actually numbers that we can achieve in many cases.
And with that, we'll move on to question 4. Do I need RTK corrections? And if not, how are corrections achieved?
Well, I kind of answered that question because there is no radio connection between the units like it is in RTK, whether it's a data connection between the base and the rover. That's not the case in this situation. Every single unit can be used as, let's say, a base station and a rover. And what they do is they individually send data sets to our cloud. And that's where the data is combined, calculated, and shown the results in our platform, Parvamoti, the MMS platform. So to be specific, you don't need RTK corrections because it does fast static calculation of vectors only, but only post-processed. I hope that answers the question a bit, Dan.
It does, thank you.
Good,
right.
Good.
Question 5. Will the Locator One work anywhere?
Anywhere. Let's define anywhere, because that's a wide area to work. The answer is no. Obviously, if you use GNSS, you're a bit familiar with GNSS. You know that you need open sky. Underneath trees, in tunnels, no, just simply doesn't work as it's supposed to be. So one of the things that we need is we need an open sky. We need to have a clear view of a constellation, let's say the 5 constellation of satellites that we are actually tracking with the Locator One. That's one of the important ones. The other one is that the communication, as I explained just now, the communication from the units to the cloud requires an LTE-M network to be present. And that's not always the case. Although we must say that LTE-M in Europe is there in most of the places. Only the far remote places where there's no cell phone reception in general, LTE-M is not there as well. That being said, so far so good. There are regions like, for instance, Africa, with the exception of South Africa, for that matter, there's no LTE-M network at all. China, same. South America, except for Brazil, there's a lot of areas where they don't supply LTE-M, or there's a law against it. And an example of that is in Turkey, for instance, roaming is illegal. So if you go on holidays for 2 weeks, you can do roaming for 2 weeks, no problem. If you try 3 weeks, you'll get disconnected. And that roaming on LTE-M is exactly what our devices need. So with that, those are two of the limitations of anywhere. The third one is that we use a global IoT connectivity platform. And that's because of the simple fact that we don't want to modify every single locator to fit every local demand. So we have a worldwide, a global operating network, connectivity platform, and they don't cover the entire planet at this moment. The expansion goes fast, but it's you know what it is. Exactly when you need it somewhere remote, you'll see that you'll have to find a different way to get to an LTE-M network. So I hope that answers the questions of anywhere a bit. Maybe you can add something to that, Toby.
Yeah, I was just going to say that I think the two things which are important to state is it's very easy to determine whether or not there is an LTE-M network where you are looking at a deployment. There are incredibly cost-effective LTE-M network scanners that you can use that are hundreds of pounds or less. And equally, there are now available on, and certainly in the UK on all of the major networks, there are coverage maps which are far more specific than the LTE GSM maps, which generally claim for coverage everywhere with very few exceptions. The LTE-M network maps are a little bit more honest. If anything, there are areas where we have been successful getting coverage where their network maps state that there is low to no coverage. So as I said, it is relatively easy to determine before Locator One is selected as a suitable device, or actually GNSS as a whole is selected as a suitable tool to use, whether or not there is LTE-M in that locality to be able to use the Locator Ones.
Right, we'll move on to question 6. How does the cost compare to alternative GNSS options, like a permanent install of a GNSS rover?
Well, it is. It's a bit difficult question to answer, but I'm going to try, because I'm not really. I'm a surveyor, and I've been selling surveying equipment for many years in the past. So if you look at the value of a GNSS RTK rover, I think the prices have gone down quite a bit at the moment with the entrance of mainly Chinese manufacturers or Asian manufacturers. Then again, if you look at a GNSS RTK permanent install, it's almost incomparable. The costs of these devices are so much higher than the Locator One that is specifically developed for this purpose. I think it's a factor, maybe even a factor 4 or 5 cost-wise. If you go out from, let's say, if you look at the best case scenario, but I think Toby, maybe you can add to that as well from the sales side of things.
Yeah, happy to. So from a cost perspective per device, we're talking just under £1,300 in the UK for a Locator One. And as we highlighted in the initial presentation, a minimum install would be 2. But even for a minimum install, we're still well below the cost of one of the aforementioned Chinese GNSS units that's now available in the UK. And the only additional cost you then have is the credits for the readings themselves, which actually as a model has been very favorably received. This isn't a cost for a cloud platform. This is the cost for the data receipts to the server and the post-processing on the server. And the way that works is you purchase a bundle of credits, which are then universally applied to any Locator Ones that are in your network. They also have no expiry date, so this isn't buying credits for a device that then sits on a shelf and is unused. Is you can have a pool of 100, 200 devices and a single credit pool, which is then distributed between those. And what I really liked was about the reading frequency. So if I'm only taking 1 reading a day, that is slightly more expensive per reading than if I'm taking 1 every hour. But again, this is it starts to add relative value. The more often I'm taking readings, the less expensive per reading it is. The more credits I purchase as a bundle, the less expensive each credit is. So it has some really true economies of scale in terms of both the frequency of the readings being taken and the broad adoption of the Locator One. But yeah, so on a base simplistic small scale install, we are immediately, as Tini said, if not 3 times, in cases 4 or 5 times cheaper than an equivalent GNSS install.
And one thing we need to add to that is on the cost side, because there are some other things you need to consider. On the cost side, you need corrections as well. So if you use an RTK system, you need external corrections to get values that are not even close to the values we achieve right now. So on the cost side of things, it would be much more expensive to use the going RTK GNSS options. And there's something else to consider, and that's the accuracy. If you look at the going accuracy of RTK systems, it's not even coming close to what in general customers need for 3D monitoring. So that is something to consider as well.
Tini, just on that point as well, something that we talked about previously. So this is the Locator One, and that's it. So your cost that we just mentioned and your installation, that's everything that you need. That includes your battery, your solar power, so all of your power supply permanently, your comms, everything is in that device, in that cost. If you were to do this with an alternative GNSS solution, there would be secondary costs if that was just the fact that you needed a long-term power supply, whether that's a mains or an off-grid solution, whether or not you need network solutions to get the data off-site, and as Tini's highlighted with the RTK. So from a total project cost, it's difficult to load anything additional onto the Basetime cost. There is a cable. So there is a charger cable that if you need to charge it before you take it to site, it will charge itself from solar, so you can just leave it outside. The other value of the cable is to trigger a reading. So if we've set this so that we're actually only taking a reading every 6 hours, we take it to site, we install it, we then, in theory, would have to wait 6 hours for that device to ping. We can use that cable to trigger an instant reading. So we can very quickly trigger 2, 3, 4 readings over to the platform. We can check on Parvamoti that it is definitely receiving the LTE network. We can check that it's definitely seeing the constellations that we need to, and that the device is operating correctly. So there are some very low level costs that you can add on to this. There are a number of mounts available as well. But in reality, in comparison, once you've bought a Locator One, other than the cable to trigger a reading if you need to, that is it. It's the entire cost of the hardware that you need to be able to deploy it.
Question 7. Can I install a single Locator One on its own? And what is the largest installation of Locator Ones that is practical?
Okay. These are two separate questions. Let me start by answering question number 1. Can I install a single Locator One on its own? Yes, it is possible. Absolutely. And you could actually use a virtual reference station set up to get corrections for the unit. The only limit is that it limits, again, it comes down to accuracy. With the virtual reference station network, we have been using that in the past in several projects. both nationally as internationally. And the results aren't that good in comparison to what they normally would do if you do the post-processing. So it wouldn't be advised to do so. The second question, and this is a fun one, because I've had this question before, and since I've been working for the company, this is a question you get quite often. And my first thought was, why is this such a thing? Why is this so important? So I asked my colleagues, and they said it's unlimited. Unlimited in the sense of, it doesn't matter whether you use 1,000, 2,000, 3,000 units, because they all communicate separately. They don't have to be connected to each other. They just have to be connected to the network to send their data to the server, to the AWS cloud in this case, to be processed and calculated. However, if you look at the availability, not only the availability of LTE networks, but the bandwidth of those LTE networks, that could be a limit in theory. You can imagine that if you have 800 locators in one position and they start sending out data at exactly the same time, which is possible if you set it up like that, you can imagine that it's going to be a bottleneck sending the data to the cloud. We found a very simple solution, and that is that we set the units on a different time schedule, also 24 times a day, so every hour, but the one on the hour, the other one 5 minutes after the hour, 10 minutes after the hour, etc., etc. And this way, they still get data of all the units to the clouds, processed and showing results. If you take that into account, there is actually no real limitation to the amount of locators installed on projects. So I hope that answers the question a bit.
Yeah, it does. Thank you.
Good.
So let's move on to question 8. How does the installation of the Locator One work in practice?
This is also a very nice one, because I have a simple example. I have a neighbor, and he has a 6-year-old son. And that 6-year-old son knows how to handle a spanner, size 17, by the way. That's the only thing you need. That's the capability of an engineer to install a Locator One. As soon as you mount it to the object to be monitored, like seen in the picture right now, it's turning on the screws, holding a small magnetic device that we provide with the units to, how do you say that? Remote, without touching it, stick it to the underside of the unit, and it turns itself on. It connects to the network. It uploads its first data to the clouds, and it's available almost immediately available in our measurement management system called Parvamoti. And from that moment on, you can do all the settings, you can do whatever you like with the unit. And again, my next door neighbor's son would be able to install them if he would have the attention span, by the way, which is the limiting factor in this case, I'm afraid.
Yeah, I have to add, these really do take minutes to install, if not less. It's quite astounding. Quite often we get comments about devices being really easy to install. This has surpassed my expectations in terms of how quick and easy it is, if not so much so that it's one of those things you install and then you question whether you've done it correctly because it was rather too quick and easy to do.
Wow, so yeah, that really does sound easy to install.
It is, Dan, absolutely.
So with that, we'll go on to question 9. How quickly is the data available after a measurement is taken? Is it near real time?
The answer to that is yes, it is near real time. But it depends on a number of factors. The speed of the network. Again, do we have a bottleneck? Yes or no? Is there a lot of traffic on the network? But on average, we say that the data is available between 5 and 10, 15 minutes max. So it isn't real time. Absolutely not, because otherwise we wouldn't achieve these accuracies. But it's, in our opinion, it's near real time. What do you think the market thinks about 5 to 15 minutes, though? Is that near real time?
I think the important thing is when we reference back to the fact that this is not intended for dynamic, rapid structural movements or geological movements. This is slow rate 3D positional monitoring. So there have been questions about whether this would be suitable for embankment monitoring, for example, which absolutely, yes, it is. But if you are expecting it to provide you a trigger an embankment collapse instantaneously with a latency of a few seconds, it's not going to do that. So it will provide you with better data than a tilt sensor on a stake over a long duration to see whether or not there is gradual failure or movement of that embankment. But if you need the instantaneous trigger that it has failed and it has failed now, this is where, again, we were talking about it being part of a toolkit. It isn't always the complete solution, but it can provide you significantly more data and representation than other devices that are available for the long term. And in that instance, that latency of data readings is more than accurate. It's when you need that then instantaneous, within seconds or sub-second notification that a secondary complementary device would be needed to trigger that.
Thank you for that. So we'll move on to question 10 now. How long is the data stored and can it be exported to external systems?
There you got me on one of the questions. How long is the data stored? I think it's user definable, but to be honest and straightforward, I'm not really sure what the standard time is that the data is stored. What I can tell you is what I've mentioned earlier is that our RESTless API takes care of the export of the data to external systems. As I mentioned earlier, we have been establishing, and I'm getting my list here, T4D, GeoMOS, Delta Watch, Atlas, and Kronos are some examples of where we connected it to. So yes, that's absolutely possible. Yeah.
Okay, brilliant, thank you. Question 11. What happens if a sensor is moved or stolen? Can this be detected?
Yeah, if you get an alert that the system has moved too much, it's probably stolen. Now I'm just kidding. There is an accelerometer inside that actually takes care of that specific instance. So yes, you can see. Yes, you can set an alert to show that it's moved too much, which is automatically done, by the way. And the problem for the thief is that the unit will actually keep sending out its location. So it would be fun to find one at a specific location. But then again, moved is one of the things that happens because of the simple fact that we use settlement rods. The purposes of the Locator One in settlement rods, where machines are in close vicinity of these settlement rods, which means that as soon as a machine hits one of the poles, one of the rods, this movement is being detected so that the user can actually go to site, have a look at what's happened, and well, whatever needs to be done to get it right again. So the answer to that in both cases is absolutely yes.
Thank you. Time for the second to last question now.
Okay.
Which industries are currently using the Locator One the most?
A two-part answer. If you look at the Netherlands, which is a country that is actually clay, sand, and a lot of semi-fluid grounds the settlement rods is the most used purpose. So that's the industry that uses the most locators at this moment. For instance, we've got a expansion of a highway, one of the most used highways in motorways, to say in English, in Holland, and they're expanding it left and right, east and west. And in one phase, they're actually using about 350 units to monitor the settlement of the underground and the settlement of the let's say the sand they put on top to preload. If we look outside of the Netherlands, we see a lot of applications in landslides. That's one of the especially in the last couple of months where we get to know more about the, let's say, the mechanisms that make landslides happen. Global warming, a lot more rain pour downs, the melting of the permafrost, and the slide type of dynamic that happens with that. That triggered a lot of organizations to buy Locator One to do those monitoring jobs. Object monitoring is another one. It's being used in Holland. It's starting to grow now, but most of the object monitoring is being done abroad, outside of the Netherlands, where they monitor bridges, viaducts, aqueducts, buildings, tunnel ends. One of the most beautiful examples we have, which is actually a Dutch one, is that a tunnel that's been installed a couple of years ago in the Netherlands, which is about 2 kilometers long. So it's not that big, but it's what they call it caterpillars. So that means there are the connecting concrete elements. They by expanding and shrinking again, they're how do you say that? The thing in between, Toby, help me. What's it called?
I'm having the same blank that you are then, Tini. I went to fill it in and it just completely left me.
It's a rubber compound to connect two concrete. So expansion, whatever, expansion things, rubbers in between, and by expanding and contracting again, dirt gets in that seam, expansion seam, so to say. So what happens is this is a permanent process. So the tunnel is actually now by now it's been growing by 5 centimeters. The problem is that if those gaps get too big, it could lose all structural integrity. So by mounting locators on the let's say the extents of the tunnel, they're actually monitoring this. And this is one of the things that it blew my mind when I heard that a tunnel could actually make a caterpillar-like movement for a structure that's so extremely huge. So it's a fun industry. And then the last one, because that is something we haven't mentioned yet, but we've had some kind of warm launch of functionality that we're actually working on really hard right now, and that's water level measurement. So where we actually use the radar on the bottom of the Locator One to measure water level. And this can be used in all kinds of purposes. And I know from history that the UK has some locations where they have floodings on a regular basis. And it could be used to remotely monitor what's going on. And I don't have to tell you about the river in Texas that rose like 8 meters in a couple of minutes. Those kinds of purposes the unit could be used. But then again, I must be honest and tell you that Toby has a lot more in his toolbox to do that much more accurately and with much more expertise.
I think it comes back again, Tini, to the toolkit and the right tools for the right job. That if there is a value in the absolute level, so for example, if we have the Locator One monitoring a fairly isolated bridge where we have the clear line of sight for the horizon as well that we need, then that could be a very useful intermittent reading to provide the current river level status. But you're absolutely right, where it is more, there's more concern over current levels, whether that's flood detection, storm drain movement, etc. Then yes, we have an array of sensors that would pair with the Locator One very well to be able to give both accurate dynamic readings on the water levels and flow rates and the structural behavior of the bridge or embankment or cliff face, which is adjacent to that.
We'll now move on to the 13th and final question. Are there any successful use cases of Locator One deployments?
Okay, it would be a bit strange if I would say no right now, right? Yes, there are many successful use cases, and so many that we've even put some on paper, which are available in many languages, amongst with English. I think we have a number of use cases that have been written out. There are many more coming, but we're trying to get as much feedback from the market, and not only to show this in use cases or white papers, but also to improve what we do. Listening to our customers has been the number one thing that improved our software, that improved our hardware, and that will continue to improve whatever we do in the future. And I think that's the only way you can actually grow with the market, is by listening to the market and working together on improving your products. Yeah,
definitely, Tini, definitely. What I will just add is, so on our website, if you scroll all to the bottom of the page that is around the Locator One, there are a series of the case studies here, which they are all downloadable to be able to go in and actually read about the specific applications. And we'll be adding more to those as they're released by Basetime. They'll be updated on the website as well. So if you wanted to navigate to that on our website, to products, and then to the Basetime Locator One, and they say that information, this webinar will be uploaded onto there as well, and all of those case studies are on there.
So these were the last questions, I believe, Toby, that were handed in.
There were. So these were all of the pre-registered questions. We have had quite a few come through while we've been live, which is great. And let's start with one that is quite relevant to what we've been talking about, which is the minimum and maximum range between the base station and the rovers.
Yeah, that is something that we didn't mention yet, but the numbers that we've shown on accuracy are with the limitation of, let's say, a 4-meter baseline. So the maximum distance we advise to adhere to this accuracy is 4 kilometers. That being said, and this is an important one, the entire integrity of your project measurements of the monitoring itself is very much dependent on the stability of the base station. This sounds like a no-brainer, but it still is a, well, if the opposite of no-brainer is a brainer, then it's a brainer. It's something to really consider, putting it close to the ground in a stable situation. And as far as I'm concerned, put it on a 30-centimeter pole, pour it in concrete, as long as it's got a clear sky view and an LTM connection, it's going to do the job. But the closer you get the base station to the units itself, the higher the accuracy. And that's what you see in the specifications as well. It's a 2 millimeters plus a half ppm, which is 0.5 millimeter per kilometer. So that means that the 2 millimeters in horizontal are going up to 4 as soon as you do a 4-kilometer baseline. So the closer, the better.
Perfect. I'm slightly conscious of time, Tini, because we're going to be kicked off in 5 minutes, which is fantastic that we've managed to fill an hour. But
Okay.
let's rattle through these quickly.
Yes.
So another question about power. With no batteries, and I know that you've got in front of you the battery that is within the device. Certainly for the UK, I think this is quite important. With the amount of cloud coverage we get, how reliable is the power supply in total isolation with the fact that it has just a small solar panel and its own internal battery?
Well, let me show you that. This is what we use, and it's not even a battery, it's a supercapacitor. The supercapacitor has a capability of storing power slowly and giving it off quite quickly. If you look at the, let's say, the meteorological conditions of the UK, I don't think it's really different from Holland, but we're able to do 24 measurements on an average day for a period of 24 hours. So every hour, 1 measurement, and then still don't achieve. I think it was, but I'm not really sure. I think it was 55 or 60% of the capacity of the supercapacitor. In other words, that if you install the units in a sunny environment, we can even do more measurements a day. But in an average overcast environment, 24 measurements a day is no problem whatsoever. And by the way, in the management system, you can also see the health of the unit, which means you can see the battery health, how it's powered up, what's its level, etc., etc. So you can always monitor that.
Perfect. Thank you, Tini. That's answered 2 of the other questions, which were around power as well. That's great. But a question about the SIM for LTE-M, which is quite easily one to answer. The device is supplied complete with the LTE-M SIM card pre-installed and pre-integrated, so there's nothing to add to the device in terms of needing to plug anything into it. We have a question about the constellations. Is this a single or dual frequency system? Which constellations are supported?
It's a dual frequency on all constellations. And let me just grab the, GPS L1, L2, C, A, and C, GLONASS L1, L2, Galileo E1B and E5B, and BeiDou B1 and B2. So it's a dual constellation setup for all these 4. And if you work in the region of Japan, we also have the Japanese constellation working and tracking.
Perfect. Thank you, Tini. And the last question that we've had through is, do we get quality or confidence factors from the data? Can we visualize the sky plots for each of the sensors?
Not from our platform directly, no. And I'm going to be honest with you, I'm not really sure whether you get the quality figures in general through our platform, but it is something that I will try to find out as soon as I can, and maybe you can answer that question in a later stage, Toby, to the individual who asked that question. It's a good question, by the way.
No problem at all. Yeah, I think it's important with these later ones. If there's anything to add, we'll provide some additional commentary as feedback as well.
Yeah.
Super. So I think, Tini, that's everything in terms of the questions we've had. Thank you for everyone who's joined us. It's been some fantastic questions, both posed before and during the webinar. And I think twofold. One, there'll be, as I said, the full webinar will be published, so you can go back and watch back through it. But we'll also follow up with specific answers to each of the specific questions documented, so we can put an FAQ section on our webpage. May find it appear on Basetimes as well, so we can answer these specific questions, which have been quite commonly reoccurring. Tini, thank you. Fantastic contribution. Thank you, Dan, for
most welcome.
Acting as our host. And yeah, I think a really, really useful use of our time. And yeah, I look forward to the next Did You Know, and also lots of inquiries about how we can check whether or not the Locator One is the most suitable device. And I think that's the important kind of leave behind is, if you're not sure if the Locator One is suitable, please raise the question. We'd much rather be honest and say, no, it's not. But in so doing, we can pin down those specific applications that it is ideal and better than an alternative for. Thank you, Tini. Thank you, Dan. Thank you for everyone joining, and hope you'll join us for the next one.